So for the final session of the day before the panel, we have the Managing Director of Stack & Lou, my very good friend, Vinny Liu. So take it away, Vinny. I'm going to walk behind you.
Thanks, Brian. Well, thank you all for coming out. I know it's the last session before the speaker, the panel of speakers, so I know it's the end of a long 2 days. But hopefully a lot of the talks before were very, very interesting. What I hope to share with you all today is my experience with real-world code review. As Brian mentioned, I'm the managing director at Stack & Lou. I spend a lot of time reviewing code, and I have for the last few years. So hopefully there's something that I can share with you today that you'll be able to take away from the perspective of somebody who's been doing a lot of assessments outside of Microsoft. I spend a lot of time reviewing code. I'm always curious in the crowd, if I could just see a show of hands, how many of you are actually code reviewers yourselves? That is awesome, because hopefully you'll get all my jokes. The perspective that I come from is that our firm does a lot of work for companies in the Fortune 200. Much like yourselves, you have probably thousands and thousands of applications. You have well, maybe not Microsoft, but you have applications with a diverse array of technologies, whether Java or .NET or Perl or Ruby. So we have to look at a lot of different things very quickly in a lot of different environments. So that's again a little perspective. Well, today what are we going to talk about? We're going to be discussing how to use tools effectively and practically in the real world. There's a limited set of tools that are available commercially right now for companies outside of Microsoft, and there are certain ways that you can use them. They come with a lot of marketing spin. There's a lot of things out there that'll tell you, you just need a black box scanner. The best thing for you is a static analysis tool, and there's even web application firewalls these days, and they're just going to tell you, you know what? You just need the firewall, and you'll pass your compliance requirement. Things like that. But what we're going to talk about today is how do you balance all that? How do you take the tools that are out there, the human analysis that you recognize needs to be in there, and smooth it out? Where's the best tool to use in this to identify this particular type of vulnerability in your application code base? And we're also going to talk a little bit about code review and how that actually works, and retire a couple common misconceptions that are often repeated in the industry. Kind of my soapbox, my 2-slide soapbox of experience. So let's first talk about perspective again. Microsoft is very, very different than just about every other company out there. I mean, you guys are light years ahead of name a company, and it's true. But you've had years to develop SDL programs. There are jobs that are at Microsoft around security that simply do not exist anywhere else. I mean, the fact that you have a BlueHat conference with a whole day of SDL is amazing. But you have a lot of time, money, and resources that you've been given and dedicated towards this. And when other companies come in and they want to know, well, how do I start getting myself down this path? What do I need to do? Well, the answer that we come back with is, assess your current situation. Where are you? What do you have? What kind of resources do you have? Well, normally, people have a security focal who's been designated to lead up this project. I like to call that guy one dude with an idea, because that's usually all it is. There's one guy who says, hey, I think it'd be a good idea if we started looking at application security. And so that's usually where they start. And then they might have a few dollars to spend on it, maybe until the next budget cycle, and they get $4 to spend on it. And maybe in some cases, these companies have tools. Now, we're talking about the Fortune 100 here. I mean, our firm has worked with several Fortune 100, Fortune 200 companies that have started out exactly this way. Somebody, in middle management, some tech person on the security team had an idea. And, where do you go with that? Well, so, these are the things that they have. Well, what do they not have? Well, the biggest thing, of course, is willing participants. And I like to call those people developers. Then you have policies, standards, guidelines, and training. And I like to call that everything else, basically an SDL. So, you're starting in the situation where you have very, very little to work with. And, again, the next question is, okay, so we're pretty bad off, aren't we? What am I supposed to do? How do I get this thing kicked off? The recommendation there that we usually make is to take a look at an application, right? Because we know what resources you do and you don't have. Let's see what kind of state your developers are developing code in, right? Let's take a look at a sample application. And that's where the real-world code review comes in. Now, it comes in several other areas as well, but you know, the first thing we usually do is assess an application. And a little sidebar here, people often ask, what is it like performing an application assessment? And I tell them a lot of times it's a lot like a roller coaster. You know, like the previous presentation, as you can see here, I've spent a lot of time putting together cubic and quadratic graphs. But but instead of using, you know, Visio or PowerPoint, I've taken the time to hand draw them, you know, with the care that comes with that. But the reality of code review is it's a soul-sucking job, you know. I mean, you are pouring through thousands and thousands and thousands of lines of code. And I don't know anyone who goes into a code review and leaves happier than when they came in, you know. And if you've ever been on a deadline, I mean, look at the graph. It's pretty realistic, right? I mean, you got a week to review a code. And, you know, for me at least, and I find this to be true for most other code reviewers, my sense of self-worth, my self-esteem is directly tied to the number of vulnerabilities that I find. I mean, I'll start off the week very on a high, right? Like I find a lot of vulnerabilities. You know, as I go on, I start kind of losing some traction there, you know, and it goes down. And by Tuesday, Wednesday, I start feeling kind of down. By the end of Wednesday, I'm considering a career change, kind of questioning my own skills. But then by Thursday, you know, you notice something. There's a piece of application behavior that's a little bit just off somewhat. You kind of notice something a little funny. And you think it might be exploitable, so you explore it some more, and then, you know, by Friday you're in a rush to get, you know, four or five vulnerabilities screenshotted, and then, you know, of course, reporting, which is possibly the worst thing in the world for anybody who's ever had to put that together. But you know, this is sort of how this code review cycle goes. What it really represents, though, is that in the beginning you identify low-hanging fruit. And then there's a period of application familiarization where you go through the code base and you're learning more and more about the application. And by the time Thursday or Friday comes around, you really know the application fairly well. You know how the data flows, and you can start taking it to that next level where you're identifying more critical vulnerabilities. So to illustrate and to drive home some more of the points about where to use tools and how to best use them, we'll use a case study based off of a company we did some work for a few months ago. We'll call them Acme Air. Acme Air provides maintenance services for companies like, say, NetJets or you know, one of the Marquis Jet or one of those, you know, airplane providers. And they have a portal that provides for real-time communication between airplanes that are in flight. So it's for prognostics and diagnostics information. You go to this portal, you can get real-time feeds on the status of the airplane. And it's the kind of stuff that if, you know, it's a communication portal, so if Bill Gates is flying back to Seattle and he feels like a cheeseburger, this is a system that he uses, so he has a cheeseburger when he lands. But in this application, the three example vulnerabilities that we'll take a look at is directory indexing, SQL injection, within a workflow, and I'll explain that a little bit more, and security questions. So a poorly designed security question system. Well, the first one we're going to talk about is directory indexing, right? This is pretty familiar to anybody who's performed an application assessment. When you have misconfiguration on the web server, you can see that all the files within the directory, fairly standard. Now, here's another one. It's a design issue, right? If you forget your password, if you want to reset your password, you have three security questions that you set when you go into any situation, right, for your account. But in this case, there are at least three design flaws. Can any of you actually pick out what some of the design flaws are? Yes?
It's telling you which one's wrong.
Yeah, exactly. It's telling you which one's wrong, right? Anyone else? Exactly. It tells you how many attempts you have left. I saw some. Yes?
Two of the questions are obvious.
Exactly. And you can Google the last two questions, right? Because you can self-define. You can self-define a lot of these things. Yes?
And making your first car, most people's aren't going to be Ferrari or BMW or Porsche.
Perfect. Exactly. You know, the make of your first car. You know, it's a fairly limited set of manufacturers, right? the set of potential answers is very limited. These are design level issues. These are design level issues that are serious security vulnerabilities. Because what this ended up allowing us to do was to just break through the application and start resetting passwords because certain people had weak security questions. Now, the third one that we're going to look at is SQL injection in a workflow. And the reason I bring this up is because, sure, when we talk about black box scanning tools, they can go out there, crawl an application, and try to identify SQL injection points. But even the most basic SQL injection, or 1=1, will not be discovered by a black box application scanning tool if it's in a workflow or part of the application that it can't reach. So in this example, what you see is sort of a number of configuration options. Let's say you have to subscribe to certain services. You check off which ones you subscribe to, and based off of that, certain pages are made available to you. Now, if that's the case, then only certain circumstances, when certain combinations of those checkboxes are selected, does a user or a crawler have access to those pages that may contain a vulnerability. So those are the things that we're going to take a look at. And when you look at it all together, you can see that the security questions are introduced into the application at the design layer, SQL injection and development, and directory indexing when the application is thrown onto the production server. So the first thing, of course, is black box application scanning, right? So we're going to start using a tool like Web Inspect or App Scan and those types of things. Now, how do you use those? Well, what they do is they crawl through the application, they come up with a number of input fields, a number of pages, and permute several inputs in order to fuzz or to elicit a response out of the application. Now, they send those requests, they get them back, and then they analyze those results, attempting to identify known vulnerabilities, certain types of security issues. They learn from that. They might have found additional links. They might get some interesting information back, and they go through the cycle again, right? This cycle of test, response, and send out the request, get the response, analyze it, modify it, send it out again. And they go through this automated process of crawling and testing and crawling and testing. What that leads to are certain things where the black box application scanner is far better. Crawling very quickly through an application, basic intelligent fuzzing, performing predictable resource location attacks, like looking for a WSFTP log on a web server, right? Brute forcing things, looking for known vulnerabilities, as well as middleware misconfigurations. There are certain things that it's not so good at, which is taking the basic set of input or attack strings and manipulating them in a way to get the application to respond. Workflow-related issues, tracing every possible state or getting to every single possible state in the application. Very, very difficult for a scanner to do because you have to balance, well, how long am I going to let it run? What kind of impact is it going to have on my system? How do I even tell it what all the possible states are? A very difficult problem for it. Certain types of login boxes, single sign-on systems. Session management is a very, very tricky thing for application scanners. And where it just completely, absolutely fails to do any good is when you have things like design issues or contextually sensitive vulnerabilities like the security questions and also chaining attacks together. Chaining attacks is another area where it's very difficult for a black box scanner to function properly. So when we look at the three particular types of vulnerabilities, of course it's going to find the directory indexing, and it's going to find it very quickly, very efficiently, and very cheaply because it's been programmed to do path truncation, to do these types of checks. Now the security questions could be completely SQL injection free, completely cross-site scripting free, with absolutely no vulnerabilities in there. But what you find is that even if that's the case, there's still a security vulnerability, and the black box application scanner doesn't know if a question is good or bad, and so it has no context, it can't tell. And then with the workflow, it's very, very difficult for the scanner to identify with several permutations of state where a SQL injection vulnerability can be because it can't actually reach the page that's vulnerable. So the first common myth that around black box application scanners that is brought up time and time again by consultants, by people trying to sell consulting services, which amazingly is actually the same boat that I'm in. But it's the claim that as a human I'm going to find 4 times as many bugs. I'm so much better than a black box application scanner. I can find all these crazy bugs, and I'm way better. Well, the problem with that is that it's really inexperienced speaking. It's total inexperience because what it means to me when I hear someone say that is you've never been on an enterprise application assessment. You've never had to assess more than a single application at a time. Now, I mean, if you're Microsoft and you can have an army of code reviewers, that might be reasonable. But for most other companies who have 100 web applications that need to be assessed or 100 applications that need to be looked at in 2 months, there's no way for you to hire enough people in a cost-effective manner to get that done. People who claim that they can just, I mean, this is the reality of the situation. Again, another one of my cubic graphs. This is how a human works. This is the productivity curve, right? I mean, hour 1, you're using the bathroom. By the 6th hour, I mean, I'm usually getting a guilt trip from my girlfriend. And, I'm laughing at my own jokes. I may not even be talking to anyone but myself. And then, day 2 comes along. I'm getting my second guilt trip. And by the time, midway into the second day, I'm passed out. So it doesn't matter, You can't do 100 applications in 2 months. It's impossible, right? How do you improve an assessor's efficiency? Get rid of his girlfriend. Yes, that's one. Absolutely. Well, what's another way? More realistic, maybe. Right. Coffee, right? Or my approach, give them some Ritalin, even out that curve. No, I mean it's to use a black box application scanner, and I mean it's not perfect. Scanners are not perfect by no means, but they're more effective over a longer period of time, and that's the reality of the situation. Unless you're just on a lot of Ritalin, and which case you'll be effective for a very long time. But even scanners have their faults, right? I mean, you run out of memory, you get caught in a loop, you got to restart it at some point. But for a sustained period of time, they're very, very effective at identifying these things that require sort of a brute force approach. Path truncation, predictable resource locations, brute forcing type attacks. Very, very effective. Well, there's also static code analysis. Static code analysis, essentially, the way that it works, I'll go through it very quickly. I'm sure you all are probably familiar with it. But essentially using a source and a sink, going through data representation of the data representation of the data flow in an application, tracing through the application to find the path that could potentially be exploitable. Now, this is obviously, this is stuff when you go through and you review it, you only want an expert to kind of take a look at these things to validate whether or not they're actually vulnerable or not. And it really does end up being sort of a thankless job because you spend a lot of time playing logic puzzles. I mean, it's like, at a certain point, it's like putting together a puzzle of a clear blue sky. It's just you spend a lot of time maintaining state, trying to figure out where things are going. But this is the basic premise of a static analysis tool: is that you look at data flow, right? Input, output. You taint the data as it goes through the application to attempt to identify things like SQL injection, cross-site scripting, and that type of issue. Now, it's a great tool for those types of things when you're looking just at data flow. But there are a couple points in particular where it fails, and it fails miserably. The first one is where you're using certain types of frameworks. Now, one that comes immediately to mind is something like Spring. Right? Or something that uses dependency injection, aspect-oriented programming. You have an external XML configuration file. And in that case, what happens is even if you compile the code still looks to this XML configuration file for direction on how the code path goes. And there's no way that a static analysis tool, at least the ones on the market today, are taking that into account. So they have no way of accurately building a representation of the data that's going through the application. This is one area where there's a serious a failure, a complete failure, really. Other areas with data flow analysis that are problematic involve the issue that data flow really only centers around assignment or the modification of variables as they're going through an application. It says nothing about assignment. So if we look at this and say this is a potentially SQL injectable vulnerability, what happens if you look at the data flow? The data flow says, one, I'm going to read in some information from the treat parameter, from the URL, and then I'm going to store it in the streat string, right? So this is the treat. Now that treat then gets appended to a SQL query on line 7, which is a dynamic SQL query construction. Great. Right? That's SQL injection, the classic SQL injection problem. And then that particular query string is then passed to the execute query call, right? Where it's, then run and you SQL inject the application. The only problem is this is all the static code analysis tool will see when it's looking at data flow. The problem is that there's no way this will ever be SQL injectable. And this is a very simple example of how control flow, like checking the value of something, doesn't get picked up by a static code analysis tool. And so when we run these against applications that we're assessing, what ends up happening is we get up to 50% false positive rates, where control flow prevents these things from ever being exploitable. And this is just a very simple example of how that actually works. So here again, the data flow analysis falls flat on its face when you take the change in control of an application into account. So things that static analysis tools are good at involve, basic data flow analysis, improper API usage, workflow-related issue, exploring all the potential data paths, and very large code bases. Because at a certain point, the human can't take a look at, a single person can't take a look at a million-line application in a reasonable amount of time. There's certain things that it's bad at, and again, what's interesting, very large code bases. Sometimes they crash, they run out of memory. But also finding known vulnerabilities, middleware misconfiguration type issues are problematic. They're not so great at reporting still, just not producing things that are useful really for developers, and or at least not consistently. And then where they fail completely are like design level issues. So we'll see, like the security questions. It would never find, it would never know, in the very same way that a black box tool would never know what a good or bad question would be. The static analysis tool also doesn't know that. And directory indexing, because that's actually introduced past the point where a static analysis tool is used, there's no way that identifies that type of vulnerability either. Now, what it's good at doing is identifying these data paths, these workflow-related issues, and so that's where you would want to apply a static analysis tool. So, another myth that I like to dispel is the concept that I've seen in articles and I've seen people talk about, and that is, lead with the tool. Lead your program with the tool. I hear that more often than not, and I've seen companies, we've come into companies where somebody has given them that advice, and they took it, usually a tool vendor actually, and they came in and they said, hey, you know what, buy this tool, it'll kickstart your whole program, you just got to use this. Well, the problem is, as the old adage goes, when all you have is a hammer, everything is a nail. So when all you have is a black box application testing tool, all the vulnerabilities that you're looking for wind up being the vulnerabilities that the black box application scanner finds. Static analysis tool, same thing. What happens is you end up training your people around this tool. You end up building your application security policies, your process around this tool. And so any limitations that the tool has, you're necessarily hamstrung by those very same limitations because you've built your process around it. From a process perspective, train your people, build your process, do the right thing, set it up properly, and then bring in the tool afterwards to make your program more efficient. Improve the efficiency of your people with a tool. Improve the efficiency of your process, but don't design your process around the tool. So that actually takes us to expert analysis, right? People, training. Expert analysis really is the genesis of where all the tools are coming from anyway, right? Any technique or method that is encapsulated within a tool is something that a human had to come up and think of and do manually for a while until somebody wrote a tool to do it for them. And the benefit really of an expert analyst is that they can synthesize vulnerability information. They have context. They can read. They can look at a security question and say that's a ridiculous question. Who wrote this? And then they'll call you on the phone and confront you about it. But the idea is that you can chain vulnerabilities, you can synthesize these types of attacks. One thing that we see very commonly in applications is where if I'm like logging into Amazon, right, and I can modify my profile, I can update that information. A lot of times, if there's a vulnerability, and we see this quite often, if I'm able to modify somebody else's profile, I can chain that. I notice that, hey, if I can update their info, what if I can inject script code? So I parameter tamper, I modify their profile instead of mine, I inject script code into their profile. Well, what does Amazon do when you check out? Right? It takes you through that workflow process, and to make it easier for you, oftentimes it will load your address information automatically, your credit card information. Well, if I've injected persistent cross-site scripting code into one of those fields, it automatically loads that onto the page. on the very same page that I'm submitting my credit card information. These types of vulnerability cocktails or vulnerability chaining are things that an expert can do to highlight impact, to really show why cross-site scripting is particularly damaging in this in an application. So that's one great way to leverage an expert. So the next question that always comes up is, well, how do you actually perform a code review, right? And we we can always go say, well, we run tools, we do manual validation, but when it really comes down to it, how do you look at code? What is the step-by-step process that you do? Well, in general, there are 3 ways to do it: file by file, data flow, control flow. Those are the 3 ways that most people will end up looking at an application. One of those 3 techniques. Now, what does that actually mean? Well, the file-by-file technique means that you have an Excel spreadsheet somewhere, you have a list of all your files, and you go through them one at a time, reading through the application source code, trying to figure out if there are any vulnerabilities in there, right? Looking at it, analyzing it. And in general, it's very easy to do this because it's very straightforward. It's easy to track. The problem in this case, though, is some files are just absolutely enormous. Some people put all their functions or all their code into one file. Very difficult to do. And the difficulty here also is that if you're working with compiled code, a lot of times you have to jump through many different files and in order to track down a particular vulnerability. That becomes problematic. And the big thing with code review is maintaining state in your own mind of where you're at, what the state of the application currently is. Context switches kill. It's the hardest thing about code review, is maintaining state in your mind of, this particular state of the application. Well, we'll see this later. This particular state of the application will cause this particular variable to be available, which allows me to inject an attack into this part of the application. Maintaining all that state while jumping through several files, then backtracking, is probably the hardest part about code review. Is tracking all that in your brain. But this type of technique is best used for non-compiled code. HTML, CSS, JavaScript, very easy to review code this way. That's what this technique is primarily used for. The second technique is data flow review, right? You look at an application from the perspective of how the data flows through it. And usually, the common technique these days is to run an automated scanning tool against it, to look at the particular paths that it's identified, and to trace through it, validate it, look at your own paths through the application, and let that be a starting point for you. And so by looking at the sources and the sinks, you eventually go through and you identify any vulnerabilities that may exist. The problem is with this approach is that you have to also take into account the control flow aspects. You can't just look at the assignment. So when you're using a tool like a check marks or a Fortify or an ounce, what happens, and of course Microsoft, you guys have your whole suite of tools that nobody else has, but when you go through and use these tools, those things are only flagging assignment. So you have to read through more carefully and look at the control flow as well. The difficulty with data flow review is similar to what static analysis tools have difficulty with as well, and that's like third-party libraries that you don't have access to. I don't know if some data reaches a third-party library is going to be exploitable or not. Well, the only way I know is if I open it up and I decompile it. Again, context switches. You're still jumping through a lot of files, through different functions, going back and forth. You might hit the same function multiple times. The context changes are very, very difficult to do. But these tools are best, this type of approach is best used in a case where you have managed code that's easily digestible by static code analysis tools. Maybe not something that uses a dependency injection type framework or something that allows for that, or with an external XML config file that controls the flow of the application, but rather in a state where you can just very easily compile it, run the data flow tools, trace through them to get some of that low-hanging fruit out of the way. And this is always, static analysis, data flow review is always augmented with manual review. Now the third technique is to use control flow, right, to look at the application. And this one is really, if you boil it down, it's you walking through the application line by line, looking at it to see how the data and the control structures modify the behavior, change the state. This is basically everything. If you follow it and you do a thorough job, you've reviewed the entire application, except for those parts of the application where a function isn't being called, right? This only touches those parts of the application that are available. what this is really difficult, again, is the maintenance of where you are, tracking state and whatnot, going through multiple files. The reason to use control flow review would be if you have sort of where the data flow analysis fails, like Spring Framework, those types of things. So it's sort of the converse of the data flow. And what it boils down to is you want to do both. You really want to do both. You want to look at it from a hybrid approach. And this is what most people do. They look at the file-by-file technique, and they use that against the HTML, the CSS, the JavaScript that's out there for non-compiled files. They do that, and you track everything with this spreadsheet anyway, and that's the easiest way to do it. And you also scan with black box tools, you scan with static analysis tools, you validate those, you go through that process, you get what those types of tools can get as much as you can, the low-hanging fruit. You go through and you validate all of that, and then you go through yourself and you look at it from a manual perspective. You analyze the data flow, you analyze the control flow, and also the big benefit of the expert is you can look at design issues. You can take context, and combine it with the app, find where things are really vulnerable, like the security questions. And that sort of is where the expert really excels. Design issues, contextually sensitive things, looking at control flow, and then these things where, say, the black box scanner may have found a potential injection point, taking that and tweaking it, or attempting more specific permutations and performing a more detailed analysis on the application's response in order to craft an attack string to verify whether or not it's exploitable. And I say black box. I don't know if this is the case within Microsoft or not, but in the other companies we've worked at, we don't always get source code. It's a toss-up. It's a coin toss as to whether or not we will actually get it or not. So a lot of times we're assessing these applications, crossing our fingers that, we're going to get source code. If we don't, or they can't deliver it on time, we go without it. And, I mean, it's unfortunate because, it's more effective to have the code, but, it's something you have to live with. And so it sucks. But the expert analysis can take those black box analysis results, tune them, refine them, and get them to a point and really narrow down where vulnerabilities are occurring. They're not so good, and really, the expert can do everything. They can look at the SQL injection workflow. They can identify that. They can look at the security questions, and they're great at that. And they might even be able to, and they can certainly find directory indexing. But the problem with using an expert for all of this is that they're slower. And the most expensive resource and the most expensive thing in an assessment is the time of the assessor or the consultant that is doing the code review for you. There's no way. I mean, it'd be like trying to find directory indexing issues against 100 applications that, for a company. It'd be like digging a well with a toothpick. It'd be ridiculous. You would never want to pay anyone to do that. It becomes financially infeasible. So that's why you have to combine all of these approaches. But, the expert does have an excellent track record at identifying things, vulnerabilities within applications. So if you were to use, for example, prepared SQL statements, right? What would the code analysis tool, static code analysis tool, tell you right here? Well, assume it's a prepared statement. It's going to say that there's no issue with this SQL injection, right? There's no SQL injection here. This is perfectly fine. Ignore it. Your code is SQL injection free. Your SQL statements are great. But what's the problem? How is this exploitable? Exactly. It's a backdoor. It's a really poorly designed login feature. Because all you have to do is you're logging in with your username, and again, and this is a real-world example that we found. So the initial thought is, hey, it's a backdoor. It's a backdoor because you can log in with simply a username and the last 4 digits of somebody's social security numbers. Well, you don't need to know the last 4 digits because of the way that this particular query string was designed. Even though it's prepared or parameterized, what happens is that you simply have to choose a value 0 through 9 and supply that. And as long as the last digit of their social security number matches it, then what happens is you've bypassed that login because they're using a like query, and you've logged into the application. But what else can you do with this? The other thing you can do with it is you can extract that username's social security number. And the way that you do that is by guessing the first digit, which is the last digit of their of their social security number. Then you guess the second to last digit, 0 through 9. And then you guess the third to last digit, 0 through 9. because every time you know when it's going to match. When it matches, you log into the application. These types of issues a static analysis tool will never find because it looks at it and it says, hey, it's a prepared SQL statement. You're fine. Go home. That's one example. So another example, Acme Air Corporation, that we looked at is a way to steal airplanes, while they're flying in midair. We talked about the application where Bill Gates can order a cheeseburger before he lands. Well, how does one go about stealing an airplane? Well, if you'll ever seen Air Force One, you can hijack it, right? Hold Harrison Ford hostage. There's always that possibility. And, come on, who hasn't considered that at one point? But that's not always feasible because, why go through all that trouble when there's an application that is managing this airplane as it's flying through the air, right? Why can't we steal it some other way? So what's plan B? Anyone ever seen Firewall? Just hold Harrison Ford hostage again. Right? Because, hey, he's a security expert, right? I don't know. I don't know about you guys. Actually, it's interesting because I actually saw Firewall on an airplane. Which is, and if that's not being held hostage, I don't know what is. But, the premise behind this is we're getting Harrison Ford back for that movie, and we're going to make him hack into our application. So how do we do that? Well, we look at the application, and we say, okay, and what we're looking at here, just to give you a little precursor so it's not just completely out of the blue, is a state attack, right? A discrepancy in state within an application. These are things that the black box scanner and the static analysis tool will never find. This is why we have humans. So in order to update your airplane information, think of it as an airplane profile. This particular application checks to see whether or not you have the right to access this particular airplane, airplane ID 100. Airplane ID 100 belongs to me. I own that. I can log in and edit it. Now, before it allows me to submit the information, it performs a second check, check B. Check B verifies to see whether or not I have update, and this is important, whether or not I have update privileges, and then whether or not the airplane that I'm submitting the details, whether that ID matches the ID that it stored when I first accessed it on the server side, right? So I'm not trying to modify an airplane that I don't have access rights to. But let's look at the code behind it, right? Now, a black box and a static analysis tool will never notice these things. The first thing with check A is that it will take the information from the airplane ID, read it into a string, and the code that we saw actually set the server-side session attribute, AID, to be the value of the airplane ID. Great. So now it knows later on when it performs that check B, that's the value it's going to use to compare, right? So now I'm not trying to, try to access one and then manipulate the parameter to access, airplane 200. Great. Well, then what happens is then it checks to see if actually are you allowed to access this plane? Yes or no? Well, if no, then it kicks you out. If yes, you go do your thing, and at the end of it, it removes your airplane ID value on the session side. Now, the two things here is one, there's a trust boundary violation where the airplane ID value is read in from the query string and it's passed in to the attribute and it's set there. But the second problem is that it never invalidates the airplane ID in all cases. If we hit that error condition, if we try to access an airplane that we don't have access to, the attribute gets set. But what happens is the AID session attribute doesn't get cleared. Right? That's important. So as a result, and like the ISEC guy said earlier, a very important point, session variables are not synchronized. So as you'll see later on, we'll take advantage of that. Well, check B, before we're allowed to submit that information, the check occurs in two phases. The first thing is it verifies to see whether or not you have the right to update. The second part is a check to see whether the airplane ID that you're submitting is the one that you originally tried to update and modify, right? But the problem here is that you check to see if the user has the update privilege, and then you check to see if the airplane hasn't changed, but you never check to see if the user has update rights against that airplane. And that's what leads to this particular vulnerability, is that if I own airplane number 100, and Han Solo who's also hacking himself at this point, has airplane ID number 200. What happens is I pop open airplane, number 1 in browser 1, and the session variable for myself is 100. What I do next is I try to access airplane ID number 200 in a second window. But we know that I can set the airplane ID, error out because I don't have access to it, yet it still resets my airplane ID session variable to 200 because there's a state that I can follow through the application by using 2 concurrent accesses to an application to trigger this particular vulnerability. And then what happens is I simply submit the original form in browser 1, which has all that necessary information. I change the owner ID and I change the airplane ID. I overwrite 200 and I've stolen the ownership of the airplane. Now the owner of that airplane is me, and I can cancel Bill Gates' cheeseburger if I want to, right? And now we're in charge of the Millennium Falcon, right? We've gotten Harrison Ford to steal this beautiful craft for us. Well, that's a highlight of how black box application scanning tools are very effective against certain types of vulnerabilities, how static analysis tools can be used against certain types of vulnerabilities, and how the experts necessary not only to validate all of those, but to take it a step further, to look at it from a perspective where the machines and the tools aren't able to analyze these things properly or get context around them. What we've realized is that it requires expert analysis for the design issue. The inspection tool really is the best thing to do against a SQL injection vulnerability, and a functional testing tool or like a black box application scanner is the best thing against directory indexing. Those are the most effective means for these types of vulnerabilities. And you have to use all 3 of them in order to have an overall effective security or software security program. So basically, you got to have the right tools, using them the right way, at the right place, in the right time. So, thanks. Any questions?